Before we proceed to another illustration for the generalized principle of inclusion and exclusion, let's talk about again this notation which already satisfied in the previous video. Though that video was in the illustration of the GPIE, we're able to understand the result if we're talking about the E of 0 when m is equal to 0, because the formula for the generalized principle of inclusion and exclusion is E of m is equal to the omega of m plus minus, that's minus, you have m plus 1 combination m, you have omega of m plus 1 minus alternating plus m2 combination m, and you have here omega of m plus 2, then minus so on and so forth, plus you have your negative 1 q, was it q? Let me check again my notes. Minus m, you have your combination of q properties taking m at the time, and you have here the omega of the q. Okay, and then if m is equal to 0, then this is what will look like. E of 0 would be the omega of 0 minus 0 plus 1 combination 0 omega of 0 plus 1, okay, plus 0 plus 2 combination 0 omega of 0 plus 2 minus in the previous video we actually end up until 4, so let me also add it here. 0 plus 3 combination 0 omega of 0 plus 3, you have plus 0 plus 4 combination 4 omega of 0 plus 4, then this is where we generalize here, minus and then plus again negative 1, so your q is q minus 0, we don't know q is, so q combination 0 what do you call this one, omega of q. Okay, that is m if m is equal to 0. But if we're going to look at these combinations, all of this even until here, you would see that they are our r is 0, and when you have combination for any n taken r at a time, all of them will be equal to 1. That is why our next part here, you would see that E of 0 when m is equal to 0 is actually the omega of 0 minus omega of 1, because that's 1, plus omega of 2 minus omega of 3, all of them with 1. Again, for the combinations, you have omega of 4 minus ... until plus negative 1 raised to q omega of q. What does this imply now? If our m equal to 0, so we simply need to operate all of this. Again, this is where our we are going to take the sum of all those elements having proper 0 property, 1 property, 2 property, 3 property, until the q property here. Okay, so with that we can see here that if what does this mean? Okay, what does this imply? E of 0 meaning elements. Okay, this is the number of elements having none of those properties, those q properties. Okay, actually this is used because there are some problems that cannot be taken straightforward. We're going to use the concept of complements. Okay, so say for example, if there is in the next video we're going to talk about number of integers as solutions for a certain string of algebraic expression. So if we cannot actually, and if we are given with, say for example, x sub 1, x sub 2, and x sub 3 have different characteristic, or a certain characteristic that can't be solved in a straightforward manner, especially if it involves inequalities. If we're going to use the complements, okay, we're going to use the idea of the complement of that problem, okay, and then solve for all of this and use this perspective, meaning in the complement of, say for example, there is a question, we solve its complement, and we have solved or used this E of 0, where identified that the result is none, okay, none of the q properties, and it's the complement. Okay, so by by double negative property, meaning the none of the properties, and this is the complement of the problem, this actually answers our problem at hand. So for example, again, we will have a situation later on. Again, we will verify it in the next item. There are x sub 1 plus x sub 2 plus x sub 3 is equal to something. However, we are tasked to identify the number of integers, solutions for x sub 1, x sub 2, and x sub 3. But it's not straightforward because x sub 1, x sub 2, and x sub 3 would be in inequality form. So we're going to get its complement. We're going to reverse the inequality, solve for E of O, and since E of O stands for none of those properties that are reversed, so the complement of the none answers the problem at hand. We'll have a situation for that later, because when we talk about this, when we're going to use this, in that the problem talks about not straightforward, as there are a lot of, say for example, less than or equal to something. So we're going to solve for E of 1, right? If it is included in the inequality, then E of 2, if it's included, E of 3. We might have multiples of this, and take note, it's very complicated for some because we have here our combinations. But if we're going to use E of O, where all of this will be equal to 1, yielding to this simpler formula, use that as a complement of a problem that resolves the problem at hand. We'll have an example for this in the next video, so please stay tuned. Thank you very much for watching.